Hello again. Welcome back to the Mark Chi School for kids who can't code good and want to learn to do other things good too. So today, it's been a while actually, thinking about it since my last video. I went away for a little bit, went down to PAX in Melbourne, and I was actually teaching very different stuff down there. I was teaching people how to paint miniatures. It was a lot of fun. And then I got sick after getting back, so it's been a while since my last video. But I still wanted to continue with what we were doing previously, which was looking at variables and input, and also the ongoing project that I've been working on the channel, which I haven't even started the project itself, which was to build up this idea of a Dungeons and Dragons simulator. So simulating some of the things that are going to happen in Dungeons and Dragons. So let me go across to the scene. Here's the code that we were working on last time. At the end of the last video was in Python, working on storing some information like this variable here, doing some manipulation of that variable with some basic arithmetic, and also being able to take user input and things. So what I want to work on today is a reasonably simple version of one of the ideas of the ways that we do things in Dungeons and Dragons. That's going to be an attribute calculator. So one of the ways that they tend to do attributes in Dungeons and Dragons, if you're rolling dice for attributes, we'd roll 4 6-sided dice, and we take the highest 3. So let me remind myself in my file what the purpose of a particular program is when I'm going to create it. This program will, let me see, do some simple work in calculating an attribute. The player, so this is the, when I refer to player here, it's going to be the human who is using this program. So what we're going to have is the program will run and the player will do certain things. So the player will roll 4 dice and input their values. So I'm continuing with the idea that we're going to be storing things in variables and using things like user input and our output and stuff so that we can learn a little bit more about what's going on there. I was about to say we. I say we a lot when I'm talking about the program, so I don't know, maybe I've just got like this kind of connection with the program. But I'll say the program will add up the highest 3 out of the 4 values. So we've got an interesting thing going on here where I know what I'm going to do, and I know how a human would think about how to do it, but what I need to do is break this down into some simple ideas that that my Python program is going to be able to handle. So we can start off with the basics. So if I go back to the files I was using previously, I can print messages, I can print numbers, I can print out just text that I put here. So I'll start with a print statement just to give the user a chance to understand what's happening. Welcome to the attribute calculator. Then what I'm going to do is I'm going to ask the user to input some values. So I'm going to start off simple, where I'm just going to say input please enter the result of a die roll. I should have set up a dice camera, actually. No, it's alright, it's alright. We don't need to get that specific about things. I do have a bunch of dice here, so I can actually do some live die rolls. I'm just pulling them out of like some gear that I have here. So let's get the camera there. I've got 4 6-sided dice. You'll have to trust me for what these are rolling. I haven't set up a separate camera for them. I guess I could, but I won't for the moment. Okay, so please enter the result of a die roll. So if you remember, when I did input, I needed that input to actually go into a variable. So I need to assign the value that comes out of input into a variable. So if I just run input like this, the input that the user gives me doesn't go anywhere. So I need to put it in a variable. So I don't know if you heard that, but a little friend has come to say hello. Can you come say hello? Aww. My cat Chicken got quite famous on YouTube over the years while I was lecturing. But she hasn't actually come in to say hi in this series ever. But let's have a little interlude to say hi to Chicken. Because she just came and meowed at me and asked to jump on my lap. So here she is. She'll sit on my lap for a bit while I'm coding. Okay, so input's going to go into a variable. So let me just call this die roll. So die roll will go in as a variable like that. And then if I want to just be sure of what I'm doing, I could print that out. So let's just, I was about to say compile and run this as a different programming language. Let's just run this and make sure it's just doing that much so far. When I'm working in the terminal like this, I can actually press tab and it'll auto-complete the closest file name to the one that I started typing in. Speed things up a little bit. Python, welcome to the attribute calculator. Please enter the result of a die roll. I'll roll an actual die and see. I got a 3. So I typed in 3, 3 came back out, so I know my input's working. Just to make this prettier, because here it's not super pretty there, I'm going to put a colon there so that people know that they can type in right there. Okay, so that is one piece of input that goes in. One of the things, though, that we might get an issue with, and let's do a little bit more and then see. So let's now do another die roll, and I won't bother printing this out now, but I'll do another die roll. So die roll 2. If I'm going to start naming these things, I'll number them. So there's going to be 4 of them. But let's just start with 2 of them. So what I'm doing is slowly building up my program, testing and running it at each stage as I go along so that you can see what's happening at each point. So rather than going all in and going, oh, I got to do all 4 of them before we start, I'm just doing each of them, doing some basic arithmetic on them, and I'll show you what's happening because there's some fiddly stuff we're going to have to deal with and fix up before we get further in. Okay, please enter the second die roll. And then let's print out die roll 1 plus die roll 2, because this is something we're probably going to want to look at. We're going to make sure that part of what we need to do for this problem is to add up all the numbers. Well, we don't have to add up all of them, but at least the highest 3. So let's run this, see what happens. So I'm using the up arrow key to do this. Please enter the result of a die roll. So I'm going to grab 2 dice here, roll them. I got 2 3s. I don't want them to be the same because, like, I'd like to show if there's any difference happening here. So roll again. I got a 3 and a 6. Okay, so first one was a 3, second one was a 6, and the output is giving me 36. What a conundrum. And I have to look at this and I go, what? What is going on here? Why am I getting 3 plus 6 equals 36? Basic arithmetic tells me 3 plus 6 should be 9, but I'm getting 36 instead. The clue there is the first number's a 3, the second number's a 6. Let's go back to some of the code that we did here. Our message is something plus message. So I started talking about this in the last video about arithmetic versus strings, and both of them, numbers and strings, both using the plus symbol. So the plus symbol for strings being letters or sequences of letters, will attach them next to each other. And so what is happening here is that die roll 1 is actually a string. And die roll 2 is also a string. The string happens to be the digit 3, but it doesn't actually have the numerical value 3. It's like the letter 3 in a sense. And so when you plus those two together, what it's doing is it's attaching them to each other, but it's not doing maths on them. It's not doing the plus the maths on them, because you can see as I hover over it here, it says variable die roll str string. So that's it saying, see if I hover over it, that's saying that this is expecting to be a string. So it's expecting it to be stuff that was typed in on input. I can, if I want to, force this input to be an integer, and then it'll have a numerical value, and I'll be able to use it in arithmetical calculations like maths. So I do this thing where I go integer, and then in brackets here, and I put the input inside an integer. What this will do is it will take whatever this string is in here and it will convert it into a numerical value. So that way it's not getting stored as the kind of key press of the 3 or the 6. Now it's getting stored as the value 3 or 6, or actually has a number value, and it'll get treated differently. So I'll make this one an input as well. Sorry, an integer as well. And we'll run this again and you'll see the difference. So this time, if I hover over this now, it says int, not string. So what it's saying now is it's knowing that this is a number value. So I'll run this again. I'll put 3 and 6 in again. This time we're getting a 9. Okay, so slight detail there. That changes what we're doing. And that makes it a little bit easier for us to work with these things like numbers, where what we've done is we've forced this thing to be a number on input. That's interesting. So if I'm forcing this thing to be a number on input, what happens if I don't get a number? So I've said it has to be an integer. Please enter the result of a dice roll. So what if I get confused and I type hello instead of a number? Ooh, I get this issue. File this attribute calculator Python line 6. Line 6 is here. Die roll 1 integer. Invalid literal for int with base 10. Hello. So the literal it's referring to is this word hello. And you cannot make a base 10 integer out of the word hello. So it's not a set of numbers that we understand in the base 10 system, which is the normal system we use because we have 10 fingers. So this is doubling up for us in a sense. So on one hand, it is making sure that our whatever we type in gets used as a number instead of a string. And on the other hand, it's making sure that if we don't get a number, our program will just go, nope, I'm not going to continue unless I get the correct input. Okay, so let us now that we're pretty sure we're getting a numerical input correctly, let's grab all of them. Die roll 3 equals, I'm going to copy paste some of this. It's not going to be exactly the same. I'm going to type in more stuff. I might just make them all the same format. Just make it a little bit more consistent. Copy, paste this line. Change the crucial parts of it. So die roll 4. Okay. Some of you who may have done some programming before are probably looking at this and going, I don't know if you should do that. Don't worry about it. If you have learned stuff, if you've learned tools that would make this simpler, don't worry about it. We will be doing this again and making this work in a more elegant programming fashion. But for now, what I'm going to do is, oh, hello. Someone just jumped up on my lap. Do you want to say hello? Hello. That's not her voice, that's just me. Yeah, so if you have seen this kind of thing before and you know that we could use things like looping and stuff for this, I'm leaving that out for the moment because what I'm going to do is actually set this thing up and build it a couple of different ways. Probably not all in this video. These videos are going to go long enough as it is if I just do one thing at a time. So what I'm going to do is I'm going to do this kind of what we would call like a simple, some people would call this a brute force method of just taking all the die rolls and then adding up the numbers and adding up the top three, and then I will get my result, and then I'll talk about how I make that result better in the next video. Okay, so I can roll these four numbers. Then I can make another variable called total. Is going to be adding up all these together. So you can see me actually here using the autocomplete that Visual Studio offers me, VS Code, sorry, but and it makes it easier for me to guarantee that I'm spelling my variable names correctly because it's giving me the variable name. So total is equal to all of those things add up together, and I can print out the total just in case. If I want to, also, I can actually say something about it. Total of all four dice is... Now, remember, as I said before, the plus here is going to get confused between a number and a string, because it's going to do different things depending on whether it's plussing words. So plussing words is just going to put them next to each other, or plussing numbers, which is actually going to mathematically operate on them. So if I want to say put this next to the letters that I have in the other thing, then I say, oops, I want you to treat this like a string. Okay, so now I should be able to put in four numbers and I'll get the total of those numbers. Let's run this again, make sure this is working. And we're pretty sure this is going to work because all the components here, we haven't really changed anything fundamentally, but it's good to check. And I think it's good to get in this habit when you're working with programs is to not try to write too much code before you test it. You can test code in very small portions and see whether they work. Okay, got my four dice. Just make sure the camera can see them. What have we got? 6, 4, 3, and 5. 6 plus 4 is 10, 3 plus 5 is 8. Total of all four dice is 18. Good, my computer is doing basic arithmetic correctly. Nice to know. So we're close. What we have now is the total of all the dice put together, but we don't necessarily have a way to find the, say, the highest three or the lowest one out of these values and remove it. So this is where I'm going to introduce another concept to our programming, which is the if statement. I think I haven't shown you this, right? No, I haven't. Good. So if statements allow us to ask questions of what's happening in our code. And the question allows us to actually decide whether or not we're going to run some code. So I can do something really, really simple where, let's just say, I'm going to ask a simple question, and these are going to be questions with yes/no answers. So if all I have is numbers and I'm asking yes/no questions, there's a few things that are very easy to ask. I can ask greater than or less than. I can ask is equal to or is not equal to. Later on, I think when I put some documentation in here, I'll put the files on my Patreon. If you're interested, I do have a Patreon. You can sign up to learn more. You can actually get this code in a code file to work with if you want. But let me ask a question and show you the difference between getting an answer or not. So let's just ask a simple question. So we're not going too deep into this yet. Is die roll 1 greater than die roll 2? So the if statement works like this. It says, we use the word if, then we put a question, and then we put a colon. Actually, usually it's right there, the colon. And then the program will decide whether it runs the code that is after the if statement or whether it jumps beyond it. So if the question results in true, this code ruins. This code ruins. So I could just have a print statement here just so that we can see what's happening. We don't really always need a print statement, but if I want to show you something, then I would. So die roll 1 greater than die roll 2. Okay. The first die roll is higher than the second. Note this indentation. So I press tab for this indentation. The default on mine is 4 spaces for this. I think most of them are going to be 4 spaces. Your VS Code's probably going to default to 4 spaces for a tab. Everything that is at this level of indentation here is going to run if the result for this is true. If I go back to this level of indentation, so once I leave this indented thing, let me just I'll take away the spare line that I put in there just so it's no confusion. Once I go back to this level of indentation on another line, on a new line here, this code will always run. So it's not part of the if statement, it's just part of the code. So all of this code is the same. We go line by line executing the code. When we get to the if statement, we grab everything that's indented in here and we decide whether it runs or not. The decision on whether it runs or not is this question here. So only if the die roll 1 is greater than die roll 2 will we actually run whatever's in here. So let's try this, show you how it works. So first die roll, what was it? It was a 6 and a 4, wasn't it? Okay, yeah, we'll do the same thing. 6, 4, 3, 5. So we know, because we have, you know, the basic grasp of numbers, to understand that 6 is a higher number than 4. So we're expecting to see the first die roll is higher than the second. Total of all 4 dice, that was this line here, prints out that, and then this line printed out. The first die roll is higher than the second, and that is because we asked this question and we got a true response from this true-false question. Let's run it again and flip these around and see. So now I'm going to do 4, then 6. So what I'm going to do is I'm going to say the first roll is lower than the second roll. I run that. This thing still prints out the total of all 4 dice, and then nothing else happens. So because this is false, die roll 1 is not greater than die roll 2, then there is no there's no way that the code inside, and we call it inside the if statement here, will run, because the question came up as false. So the if statement allows us to turn on and off bits of code. So depending on the situation the program finds itself in, it can decide whether or not the code's going to run using this if statement. There's even more cool stuff with the if statement we can do. Is we can have this else part of the if statement. So this ties 2 things together, and it says there's 2 forks in the road. If the die roll is greater, the first die roll is greater than the second, we go down the first part. Else, if it was definitely false, we go down the other part. And then we just kind of return to our normal flow afterwards. So I'm going to say this part's outside of the if else statement. So now I've got this else, and I say if the question results in false, this code runs. So we've got this organization of our code. So there's 2 forks, and each one's in its own section. So there's the if section. Oops, let me highlight it. There's the if section, and then the else section. So else section, I'll put another print statement in so we can always see what's happening. Print the second die roll is higher or equal to the first. So it's not necessarily going to be higher, it's higher or equal because it was greater than. So if they're both the same, then die roll 1's not greater than die roll 2, and this else will print out. So now both of our possibilities, one higher or the other higher, we should print something out, and they should give us some good information about what's just happened. So save this. I just press Control S to save. Run this again. Okay, so situation we had before was 4, and then 6, and then 3, and then 5. So this is saying the second die roll is higher or equal to the first. Let's do this again. 6, then 4. So the other way around, the first one's higher. 3 and 5. I'm just throwing other numbers in there. They're not important for the moment. 6, 4, 3, 5. The first die roll is higher than the second. So we can see that the program's looking at these numbers and deciding what to do based on comparing which of these numbers is higher than the other. So what I'm setting up here is the capability for us to look at these numbers and see which one's higher than the others. And you can see why I'm doing that, because we're supposed to add up the highest 3 out of the 4 values. So if I can compare 2 numbers with each other, I should then be able to combine comparisons between all 4 numbers and figure out which of these numbers are the 3 highest, or which one is the lowest. Because I could, if I wanted to, find the lowest number of the 4, and I've got a total here, and so I could find the lowest number of the 4 and minus that from the total, and then I would get the sum of the highest 3. So this is an example if statement, and I'll leave that in there just as a reference. People can use it in the code file. So this isn't going to do anything in particular, but what I'm going to do now is say to add up the highest 3, we can find the lowest number of the 4 and subtract it from the total. And then that should give us our final answer. So, how do we find the lowest number in this set? If I can ask a question, one question at a time, which is if one is lower than another, then I should probably be able to do this. So I'm trying to think about different ways I could design this. I didn't actually do this one in advance. I like to sometimes not be 100% prepared when I'm coding, because then I can talk my way through my decision making. So I've got a simple question like this: if die roll 1 greater than die roll 2. So I'm going to use the same question as I did before. If die roll 1 is greater than die roll 2, then I know that die roll 1 is not the lowest. So I've just narrowed down my problem. Now I'm only looking at 3 numbers. So if die roll 1 is greater than die roll 2, then die roll 1 cannot be the lowest. Which means now I need to look at die rolls 2, 3, and 4 and see which of them is the lowest. This could get fiddly if I start kind of looking through all of the numbers in a kind of a, if die roll 1 is high, then I look at die rolls 2, 3, and 4. Let me switch to a whiteboard for a second and show you kind of what I'm talking about. So there's die roll 1, die roll 2, die roll 3, and die roll 4. So let's call these D. I don't want to write out the full variable name because I'm writing on a whiteboard with a mouse at the moment, so it's not too pleasant to try to write large words. So what do we had? We had 6, 4, 3, 5. And we're like, okay, I'm going to add up the highest 3 out of this. As a human, it's really easy. As a human, I just go, yep, just take out the 3. It's the lowest. The computer needs to figure out what our actual process was there. So we have a way of thinking about this where we look at all the numbers and we know which one's the highest, which one's the lowest, and we go, all right, we can see the lowest. It's clear. But what we need to do is break this down from us kind of intuitively looking at the numbers into a method that the computer can actually use if it can only look at two numbers at a time and compare them. So let's think for a moment that we don't have the simple option of just looking through all of them and just going, I can see the lowest, right? We have a certain amount of human, it's not really, it is intelligence. I mean, but that's a very big word for our kind of experience with numbers. If we have experience with numbers, we can just pick out the lowest. But the method that we used to find this was kind of to look through all of them. And we looked through all of them one after the other, and we decided which one was the lowest. So what we could do is we can say, let's look at these two. We look at these two, we can find one's higher than the other. So 4 is the lowest. So what I might actually do is create a variable. So as a human, I wouldn't do this way, right? But a computer's going to be able to do this quite nicely. So I'll create a variable. So if I have 6 and a 4, the lowest of those two is a 4. And then I won't necessarily compare this with the 3. What I'm going to do is I'm then going to compare this. And I'm going to say, I've checked the first two, now the third one. Are you lower than the lowest? So the lowest I've seen out of the first two is 4. And then they check whether this lowest is lower than the third roll or not. And I find that the 3 is lower than the 4. So if the 3 is lower than the 4, what happens over here is the 4 is no longer the lowest, because we've seen that it's higher than another number. So I'd cross this out, replace it with a 3. If this is a variable in my program, I don't have to cross it out, right? I just assign a new value to it. And then I look at this one here, and I say, the lowest we've seen so far is 3. What's your number? Your number's 5? That's right. I'm lower than your number. That's my lowest. So I've done, I'll draw arrows, one if comparison, another if comparison, and another if comparison. I should be able to get this done with just 3 if statements. So here's our plan. Let's go back to our code and try to enact this plan in the code. So if die roll 1 is greater than die roll 2, I know that die roll 1 is not the lowest. I don't need to say I know that die roll 1 is not the lowest now. I can say I know that die roll 2 is the lowest so far. So what I'm going to do now is create a variable called lowest so far. It's a bit of an unwieldy name for a variable, but it tells us exactly what it means. Lowest so far doesn't have a value yet. I'm just going to go on a limb and give it a 0, just because I needed a value to create the variable, and it's going to be an integer value. But whatever happens, this first if statement is going to replace that value. So if die roll 2 is the lowest so far, then what I'm going to say is the lowest so far is equal to die roll 2. Otherwise, if this if statement comes up false, I can say I know that die roll 1 is the lowest or equal lowest. I don't mind if it's the equal lowest. Equal lowest is, for our purposes, the same as the lowest. So, if die roll 1 is not higher than die roll 2, then it's the lowest so far. Oops. I know I was talking about auto-completing these things before, so I didn't spell it wrong, and then I just went and typed it and spelled it wrong. So, both forks here are replacing lowest so far. So this value of 0 will never get used. I just needed it because the variable needed a value to be created. So, starts at 0, but immediately gets replaced with either of die roll 1, die roll 2, whichever is lowest. Then, referring back to this, my monitor's so bright, I hope you can see that my face, it just like slammed me with white light. Okay, so we have the lowest so far, and we compare that with the third number, the third roll. And whichever of those is lowest becomes the lowest so far. So, if die roll 3 is less than lowest so far, I'm going to say, if I'm in here, die roll 3 is lower, replace the lowest. So I go, lowest so far is now equal to die roll 3. So this only happens if die roll 3 is less than the lowest so far. So in our example here with the 6 and the 4 and the 3, 3 was lower than the 4. So then the third roll's value, which is 3, just happens to be the same at this point, 3 is 3, replaces the lowest so far. Interesting thing about this one is I don't need an else for this one, because if the die roll 3 is higher than the lowest so far, I'll ignore it, because it has no relevance, because I'm looking for the lowest number. We can ask the same question of die roll 4. Is die roll 4 lower than the lowest so far? If it is, we'll get into this if statement here. Die roll 4 is lower, replace the lowest. It's the same comment as previously, because it's actually a really similar if statement. So, lowest so far then equals to die roll 4. This code here, this sequence of if statements with a variable is going to go through and do this. Check which of these is the lowest. That becomes the lowest so far. Check between the lowest so far and this number. The lowest of the two of them is the lowest so far. And then check between the final number and the lowest so far. Whichever of these two is lower becomes the new lowest. I might want to put some information in here so that when I run this, I can see whether this is actually working for me. So, definitely at the end of this, I'm going to print out lowest roll was, make it a string so that I can print it out, lowest so far. So it's not just lowest so far. Now that we've looked at all 4 of them, it's the lowest in general. So the lowest roll is the lowest so far. So let's just get that and see whether that works. But what we want to do is probably print out some stuff in here so that we can see what's happening. So I was about to type the variable name, but I don't have to, because this is the bit that talks to the human. So this says the second die roll is lower than the first. So what I'm doing is just putting some information here. I didn't really need to copy paste that. First die roll is lower or equal to the second. Here I will print out third die roll is lower. I probably don't need super amount of information. That's probably enough information. This is fourth die roll is lower. So all I'm doing here is just adding some of these print statements so that when I run this program, I can see which of these things triggered. So I can see, did this happen, or did this happen, or did this happen? And I can just read out what my program is telling me, because I'm basically asking my program to think out loud here, so that when it does its thinking, I can look at it and see whether it worked or not. So let's run this and see how we go. Okay, so let's put in the same situation we had here, 6, 4, 3, 5, and we'll see if it did the same thinking we did, where you pick the 4, and then you pick the 3, and then you ignore the 5. So let's run this with 6, 4, 3, 5. and see what it tells me. So 6435, total of all 4 dice is 18. That is this line printing out here, total of all 4 dice, then adds it up. And then it says the first die roll is higher than the second. Okay, first die roll is higher than the second, which means that the second number, the 4, was the first lowest. The second die roll... Oh, wait. That was the example if statement, was that first thing. The first die roll is higher than the second. I just looked at it and said, why are they both saying the same thing, the first 2 lines? Okay, so this is our old code here, our example if statement. This ran, and the first die roll was seen to be higher than the second. So we're actually doing the same check twice. But that's okay, because this is an example, and this is the code that we're actually using. So, second die roll is lower than the first. So that was the 4, is lower than the 6. And then the die roll 3, third die roll is lower. And then we see in here, it does not say the fourth die roll is lower, because the fourth die roll was 5, and it's higher than the 3. So, because it doesn't say this, we know that it never got inside this if statement. So it never thought that this question here was true. And that makes sense, because roll 4 is not lower than the lowest so far, because at that point in time, the lowest so far was a 3. So the lowest roll is a 3. So there I found my lowest roll, and it's worked in one case. I don't know yet whether I've written the code well enough to work in many different cases. And this is what we do when we're writing code, is we then start testing it with a lot of different options. So 1, 2, 3, 4. Let me test it with a simple situation where I know what the answer should be, and I'll test it out. Second roll is higher than the first. The first roll is lower or equal to the second. So this was the tester here. First die roll is lower or equal to the second. Third die roll was not considered lower. Fourth die roll is not considered lower. Lowest roll was 1. Okay, that's pretty good. That's getting the right answer. And reading it, I agree with the logic of what it did. Let's run it again and reverse that. See what happens. First die roll is higher than the second. Second die roll lower than the first. Okay, so this is this thing saying the first die roll is higher than the second. And this one says the second die roll is lower than the first. So that means that the 3 is now the lowest. And then the third roll was lower, because that's a 2. The fourth roll was lower, that's a 1. So I'm getting a 1 here. This is nice. What I'm seeing is that I did it in one order, I did it in another order, and they were both correct. Let me show you some weird stuff we do with testing. What if all the numbers are the same? Total is 12. Good, that's correct. The second die roll is higher or equal to the first. That's what we said here. And this one says the first die roll is lower or equal to the second, which is also correct if they're the same. And then it didn't trigger lower for the third or the fourth, because they're not lower, they're all the same number. And the lowest roll was 3, so we're actually still getting a good response out of this thing. Let's go all out. Negative 99, 526, 6,000 million, billion, and 1. It's worth testing, you know. The total for all the dice was 6. I didn't even know what that was. 6 billion? I don't know. I'm not going to count the zeros. 6 something and 428. The second die roll is higher or equal to the first. So the second is 526. The first is negative 99. Yes, 526 is higher than negative 99. And then the negative 99 means that nothing else ever got triggered. So my lowest roll was negative 99. I do not know the kind of dice necessary to make those rolls, but I do want to test my program, so I'm happy that it works with negative numbers, it works with gigantic numbers and things. You know, it's nice to just kind of see it working with other options. Okay, so I know what the lowest is. So if I know what the lowest is, the attribute total was, where are we? Total of all 4 dice is here, total. So if I've added up all 4 dice and then I subtract the lowest of them, I'm going to end up with a result of the highest 3 added together. So, let's make a new variable. The result equals the total minus the lowest. So we're still calling it the lowest so far, but since we've gone through all the passes, that's actually the lowest. The result is this. Print. I'm going to say explicitly what this is. The sum of the highest 3 rolls is, and I want this to print out, so it's a string, is the result. Alright, let's see if this worked. I mean, there's going to be a whole lot of printout stuff, but we'll see if this works. We're just going to look for the last line here. I'm going to roll actual dice. Oh. I'm going to type this in because it's what I rolled. I rolled 1, 1, 1, 3. If this is your Dungeons & Dragons character, I'm very sorry. They're going to have one very bad attribute. Total of all 4 dice is 6. Lowest roll is 1. Sum of the highest 3 rolls is 5, which is correct. 3 and 2 ones. Very, very unfortunate character. Let's try this again. I'm going to roll the dice again. Okay, it got better. 4, 3, 6, 3. Total is 16 of all 4 dice. The lowest roll was a 3. Sum of the highest 3 is 13. So 6 and a 4 and a 3 added up is 13. Program appears to be working. Let's try it one more time just in case. I mean, we've tested it a little bit already. Ooh, high roller. 5, 5, 6, 6. Okay, so this character has one glaring weakness and one really powerful capability. So total is 22, but what we're looking at here is 2 6s and a 5, which is total of 17. Great. Okay, we've got this working. So this code will add up 4 dice, and it will find the lowest of those 4 dice and remove that from the sum. I did this with a very, very simple set of programming procedures. I didn't want to add in too much complexity, so the only thing I did was an if statement with an else. So all I really wanted to show was getting some input, doing some arithmetic with it, and just making decisions based on the input that came in. In subsequent videos, I'm going to expand on this. We're actually going to stick with this attribute calculator for a little bit longer, because I have some questions to ask. If we wanted the highest 3 rolls, we were going to be polite to our players. What if I wanted the highest 3 rolls from 5 dice? Or what if I wanted the highest 3 rolls from 8 dice, or something like that? This code can't do that. This code is really, really locked into only taking in 4 variables, and then finding the lowest of those 4 variables, and then minusing that from the total. So it's not very capable of doing a lot of things. It's also a little bit set in its ways. It has a bit of code here, this section, which is very repetitive. When you write the same code multiple times like this, it's a little bit dangerous, because what if I wanted to change something fundamental to my input about like what I was telling people? Then I'd have to edit all 4 lines. There's ways to do this that makes this much more kind of, I don't know, elegant, I think would be the word. And so in my next video, I'm going to come back to this same situation and teach people about writing code that does the same job, but it does it in a way where it can be modified and used in more situations than we have just here. So this is very, very specific, and uses only the simple tools that I've shown you so far. But we can actually expand this to make it more interesting. But I should leave it there. This is... Every video I record is now my longest video that I've recorded. It's pretty funny. But I'll leave it there. If you're interested, I will put a link in the description to my Patreon. You can sign up there. I will give you the source code, and you'll be able to play around with this and see how it runs. I mean, if not, you can always just type it in. If you don't want to be on the Patreon, that's totally fine. I don't mind. Anyway, I will sign off there with this attribute calculator. But what I'm going to do next time is I'm going to start modifying the attribute calculator. I'm going to start adding capabilities to it. And I'm using this as a kind of a foil to teach you about different parts of programming. So, you know, originally we looked at just variables and input. And in this video, what we've added in is if-else statements, which allow us to suddenly make choices on different things. There's a lot more things than a greater than or a less than that we can put in here as well. I haven't shown you that, but I'll show you some tricks about that later, or I'll leave some notes about it when I actually put these files together for people. All right, thanks for listening. Thanks for sticking it through to the end if you did so. Would love a like and a subscribe if you're up for it. Love doing the YouTube thing. And I will see you next time for more Python programming in the Mark Chi School for kids who can't code good and want to learn to do other things good too. See you around.